Hello and welcome to the session on object-oriented programming with Python. In the time that you have spent with Python or even before that, you may have heard that Python is an object-oriented programming language. That's a pretty big jargon, so let me break it down for you. So being an object-oriented programming language is one of the most powerful features of Python. The paradigm of object-oriented programming lets you think about everything you create in terms of object and the interaction between them. For instance, when you store someone's name as a string variable, you are creating a string object. When you store someone's date of birth as an integer, you are creating an integer object. When all that you create gets created in terms of objects, you don't have to worry about memory, bytes, structure, union, or references and address pointers. This gives you a more naturally relatable language and an option to have a pre-built set of methods, functions, which could be directly used by an object. Now, just like we use def to define a function, we use a class to construct an object, and we'll get to that in a second. The word class is the keyword used for the construct. Based on the class used to create an object, you get the pre-built methods applicable to them. Now that the benefits of this feature might not be seem huge to you at the present, I have to say and kind of promise you that you'll cherish learning this by the time we end this session. In the next video, let's learn more about objects and classes. When dealing with objects, some attributes are going to be unique and some will be shared. Let's say each student in a classroom has same room number and same teacher, but obviously they each have a unique name, age, and favorite subject. So let me define this class first, and we can discuss on what we mean by class variables and instance variables. So I'm going to define a class student with the name of the teacher and room to be like, kind of preset, but these are parameterized. So if I, let's just also instance them. So let's have Tom to be an object of class student. And obviously we need to pass these three parameters here because they are dynamically assigned. So the name is Tom, the age is 15, and the favorite subject is math, for instance. Right, so if I then print Tom dot teacher and Tom dot, just say subject, I'm gonna get Mrs. Jones as the name of the teacher and math as the favorite subject. Class variables like teacher and room are usually variables that are shared by all instances. So from the formulation or the problem that you are going to solve based on the application, you know which variables are going to be shared and which are going to be specific to each instance. For class variables, each instance of the class will have the same value of these variables. Instance variables, on the other hand, are going to be specific to each instance of the class. So they are unique to each instance of the class. Let me define another object of this class, Susan, of the class student. So the name is Susan, age to be 16, and the topic to be English. And I can just print, Susan, let's just print teacher just to get the, and Susan dot age. So if I do this, I get again Mrs. Jones and the age to be 16. So just to recap, each instance of the class had unique values for these instance variables, and they all share the same class variables. So these are the technical terms that are assigned to these types. These are class variables, they are shared among all the instances, and these are instance variables that are unique to each instance. Another thing that you can do is that you can call the class name and change the teacher name. So you are not using any object here. You're just calling the class name and changing the teacher name to Mr. David. Okay. So if I now go back and print the same thing, I'm gonna see Tom's teacher to be Mr. David, and the favorite subject is still math because fifth. So this line of code here in block code 8 is doing like changing the class, the definition on this class variable name from Mrs. Jones to Mr. David. So that's also another technique you can do if at some point in the code you may decide that, okay, I want to change the class, and yeah, I don't want to go back and change the class at the place that I have defined it, but I just want to change it here. So that's the place, that's a way that you can change the teacher, the class variable, by assigning a new class variable. So this is what we call class variable and instance variable, and these are again objects that we have defined off of this class student. Now, as we step into the world of object-oriented programming, let me set expectation right. Object-oriented programming is a major area of programming and program design, so you won't understand all of this after just doing this course. I've been using Python for quite a few years, and still to date, I keep learning new patterns and approaches to object-oriented programming all the time. So if at the end of this course, you still feel a little fuzzy about it, that's fine. It's to be expected. Just like with any large topic area, like say algebra or baking, you'll have to spend some time researching and experimenting with it to really get the most out of it. In this session, we are going to talk about objects and classes. Python has many different kinds of data types that we get familiar with: integers, floats, strings, lists, dictionaries, and booleans. In Python, everything is an object, and every object has the following three characteristics. It has a type, internal representation, and a set of functions called methods to interact with the data. An object is an instance of a particular type. For example, every time we create an integer, we are creating an instance of type integer, or we are creating an integer object. In this case, we are creating three instances of integer or three integer objects. Similarly, every time that we create a list, we are creating an instance of type list, or we are creating a list object. So this is just to give you an overview of what objects means in technical terms. Let us start coding here and start defining a class. Here we want to define a class called rectangle, and the attributes that we have are length and breadth of the rectangle. One of the necessary requirements for a class is to have a constructor, and we define the constructor by using the init function. So you have a class and you name the class rectangle. This is the name that you choose. Here you have to define a constructor for the class, and you do this by using init like this, 2_ and then self. So you can initiate this. This is kind of like an initiation of this class. You can say I want the attribute length to be 10, and I want the attribute breadth to be 5. You are defining the two attributes yourself. These are main attributes of your class. The self parameter here refers to the newly created instance of the class. And attributes length and breadth are associated with the self keyword to identify them as an instance variable. So now let's create an object by calling the name of the class followed by parentheses. So if you do, for instance, rect equal to rectangle followed by parentheses, so you have the name of the class followed by the parentheses, you are creating an object which you call it rect. And then let's print the rect dot length and rect dot breadth. Let's see what's going to happen. So in the second block of the code, you first create an object by calling the name of the class that you have already defined, followed by parentheses, and then you print the attributes by using the dot operator. So you have this instantiation of this class, which you call rect. So rect is now your object. And now you can access the attributes by using dot and the name of the attribute. What's happening under the hood is that when you do this init function is executed, and the values, the first initial values 10 and 5 are being saved into this rect object. Now, what if you want to assign and initiate the variables, the attributes length and breadth dynamically and on the fly, meaning that you want to assign the initial variables length and breadth every time when you initiate the whole object. This is the so-called parameterized constructor. So you can define the class as you were doing above and path length and breadth as two variables here, right? And then initiate the self length as length and breadth as breadth. Okay. Next, when you define your object to be an instantiation of the class, you would do this, but now you have to pass these two parameters as well. So you would do 10 and 5, for instance. So let's do some two different numbers, 12 and 8, and let's just print the same members or attributes length and breadth. So you can see that now you can dynamically initiate the members attributes length and breadth by using the so-called parameterized constructor. This is a parameterized constructor, and what you have to pass as input are these two parameters when you first define your object by calling the name of the class and the parentheses.